In an intensive care unit, an automated medical system analyzes a continuous stream of vital signs. It processes biological data at high speeds to predict sepsis hours before a human doctor can detect physical symptoms. If that predictive model makes a life-or-death error, the hospital faces an immediate crisis of accountability. They must prove through a verifiable audit trail that they exercised due diligence over the algorithm's deployment and behavior. This standard provides the structural blueprint to organize unpredictable AI risk into a systematic artificial intelligence management system, or AIMS. The first mandatory step in constructing the system is Clause 4.3, establishing the scope. This radar chart illustrates the scope. The hospital must document their operational perimeter, technically defining exactly which algorithms are being governed by the AIMS. For our clinical use case, the scope expands to include all ICU diagnostic models. This brings the sepsis prediction tool directly inside the governance perimeter. The scope also explicitly excludes non-clinical administrative AI. Hospital billing algorithms and scheduling tools are left outside the boundaries of this specific management system. Defining the scope locks down the boundaries of legal and operational responsibility, ensuring the organization and the auditor agree on exactly what is being managed. Once the boundaries are set, focus shifts to the personnel overseeing the system. Clauses 5.1 and 5.2 govern leadership and policy. The baseline requirement is a formal AI policy, approved and signed by top management, such as the medical director or chief technology officer. However, a signature alone can lead to a non-conformity, a failure identified in an audit, when the organization's actions do not match its documented policy. Consider a specific compliance trap. A CTO signs an AI ethics policy, promising rigorous bias mitigation. But the audit reveals a budget spreadsheet for required testing tools with $0 allocated. Under ISO 42001, leadership commitment is evaluated through evidence of resource allocation. Auditors look for approved headcount, software licenses, and dedicated budget lines. Executives must also prove they review AI performance metrics and integrate the AIMS objectives into the organization's broader strategic plan. In an audit context, executive intent is measured by the capital and operational resources placed behind the policy. Clause 7, Resource Management, connects high-level strategy to technical operations. The standard mandates managing 5 resource categories: human, technical, financial, infrastructure, and knowledge. These resources flow sequentially. Approved financial budgets are used to secure software infrastructure and technical tools, which in turn support the competent personnel required to run the models. Those personnel are governed by Clauses 7.2 and 7.3. Competence and awareness must be role-specific and backed by documentation. To verify an AI developer's competence, an auditor looks for training records in machine learning algorithms, bias detection, and evidence of secure code reviews. General staff awareness is also auditable. Any employee interacting with an AI system must understand how to report concerns and know the consequences of ignoring established procedures. If a sample of call center agents cannot explain how to escalate a complaint regarding an AI-driven decision, the awareness portion of the audit fails. Operational control is the functional core of the management system. This clause requires the hospital to establish criteria for AI processes and manage system changes through formal approval logs. Annex A controls provide specific pipeline requirements. Control A.7.2 focuses on data quality management, ensuring input data meets predefined validation roles. Next is Control A.8.2, model validation, requiring documented test results and formal sign-offs before the model operates clinically. Post-deployment, the standard requires monitoring for model drift under Control A.9.3. Model drift occurs when real-world patient data shifts away from the original training data. The hospital must implement triggers to detect this drift, preventing a silent decline in the model's predictive accuracy. Control A11.1 requires the logging of AI decisions, creating an audit trail for system outputs and human interventions. For our sepsis use case, the hospital maintains a human-in-the-loop safeguard. Every AI-generated sepsis flag must be accompanied by an override log and a clinician's review timestamp. These operational controls function as procedural gates, translating the hospital's ethical policies into verifiable technical requirements. The ISO compliance process depends on the distinction between documents and records. Documents are the rules. These include AI policies, risk registers, and impact assessments that define how the system is intended to function. Records are the proof. These are the unalterable logs, validation results, and training rosters that show how the system functioned in the past. Auditors look for alignment. Do historical records demonstrate the organization followed its documented rules? Clause 7.5 mandates specific retention timelines to preserve evidence. Training records must be retained 3 years. For policies, keep the current version plus 2 previous iterations. Audit reports require 6 years, while incident logs must be kept 10 years. In the eyes of an auditor, documents represent a commitment, but records provide the proof. Without a record, compliance does not exist. Clauses 9 and 10 turn the management system into a verification loop that evaluates its performance. Clause 9.2, Internal Audit, and 9.3, Management Review, require leadership to examine performance dashboards and audit findings to ensure the system remains effective. Returning to our sepsis AI case study, we can observe the outcome of an internal audit. The audit confirmed a conformity because the sepsis model was validated against retrospective data before use. However, the auditor also identified a minor nonconformity. 2 clinicians had not completed the required training for interpreting AI outputs. This failure triggers Clause 10.1, Corrective Action. The hospital must execute a plan to resolve the training gap within a set timeframe. Every identified risk leads to an objective. Every objective requires a control. Every control generates a record. And every record is audited to drive the next cycle of improvement. The ISO IEC 42001 framework operates as a self-correcting cycle, maintaining the accountability of an AI system through continuous oversight and documented evidence.